The research is focused on the studying of the emergence of new properties when two or more molecules interact one with the other. Basically, the idea is to study the new properties when the aggregation process takes place. And for this purpose, we selected the platinum 2 complexes since they have a flat geometry and they can rearrange themselves into luminescent supramolecular structure.
At first, the platinum molecules dissolved in solution are isolated and inactive. They are able to interact with light, they can absorb it, but they cannot re-emit it. They are in a dormant state, inactive but full of potential. But something changes. By varying the solvent surrounding them, a spontaneous process is triggered, aggregation. The molecules begin to move closer together, recognize each other and attract each other. They remain united, forming weak bonds and stack face to face through interactions known as metallophilic. This gives rise to more complex structures, supramolecules. And it is precisely in these new forms that luminescence begins to emerge. Together, they can shine. Molecules are not passive, they respond to environmental stimuli. A change in solvent is enough for them to organize themselves into different geometries. The way they aggregate changes, as does the light they absorb and emit, until they find the most suitable form for that environment. But what happens when the environment becomes competitive? When multiple ligands try to bind to the same molecule? Then it is no longer just the supramolecules that change. It is the molecule itself that transforms. A phase of adjustment and selection begins. Each molecule must choose the most suitable ligand in order to survive. And it is precisely here that new forms arise, impossible to obtain in any other way. New species come to life. They can even organize themselves into a dense network, transforming into a gel. In this competitive environment, multiple species can coexist in a new equilibrium. They are no longer just platinum molecules, no longer just gels. They have become an ecosystem, a complex living whole made up of different aggregates, each with its own ligands. A stable but constantly evolving system, capable of responding to new stimuli. Could it become a photocatalyst? What other reactions could it trigger?
So the idea of this project is to create a more and more complex system that could mimic the biological living behavior.